How does the gravitational field acting on the occupants of the space station compare to that acting on you now? So in the previous problem, we showed that the acceleration due to gravity when you're at the height of the space station is g is equal to 0.9 times acceleration due to gravity on the Earth. So if we know that, we can calculate out that the acceleration due to gravity at this certain distance is g is equal to 8.82 meters per second squared. Now, let's say we had a 1 kilogram object. So on the Earth, what would be the weight of that object? So the weight is equal to the mass of the object times the acceleration due to gravity. So on the Earth, our 1 kilogram object would have a weight of 9.8 newtons. But when we're on the space station, our acceleration due to gravity is less. So our weight when we're on the space station of our 1 kilogram object is going to be 1 kilogram times 8.82 meters per second squared. Now, if we carry that multiplication out, you would find that our weight is 8.82 newtons. So here we can see that we still have gravity acting on them, so A is wrong. B is saying it's 1/3 as much. Our weight is not about a value around 3, so that's wrong. Saying it's 1/2 as much, well, 1/2 of 9.8 is 4.9. We're still at 8, so again, that's wrong. D says it's close to the same. That makes sense, but let's continue going through all of our choices. See if another one it makes more sense or is better. And then E says it's exactly the same. Well, we know 9.8 is greater than 8.82, so E is also wrong. So the only one that we're left with that even makes any sense would be answer D, that it's close to the same, which makes sense because on the Earth, our weight of that object is 9.8 newtons. When you go up to the space station, it's 8.82 newtons. It's only 1 newton less. It's nothing truly significant. It's not like you're cutting the weight of the object in half or a third. That would be more substantial. Here, this is rather small, and you're still relatively close to the same answer. So for this question, your answer is D. It's close to the same value.